Okay, so now if we now have a look at our other option, which is buying beams in from our supplier. So effectively, the idea with this is that in total, we've got a requirement of 6 entire modules which need to be finished, delivered to the construction site for the customer in a week. We're using the same 40-hour shift pattern for the plant, and we're expecting 2 beam deliveries a day from the supplier. So how does our production system look? We've also made a decision that our top and bottom frames are to be assembled in parallel, and our stud walls and windows are pre-assembled off the line, as these were known from previous knowledge to be particularly time-consuming tasks. And so we're going to hit go on our simulation for a week. We can see that our shift has started. We've got our bottom frame building up there along with our top frame in parallel, which are then assembled together with our vertical columns and our joists, which we can see here are beams which are being counted on the live graph. We can also look here at our bottlenecks. We're simulating our overall system utilization in total. We know that our architecture station is kind of taking slightly longer, so you can see that we have moved some of our assembly off the line to produce the build-up of our plasterboard and our stud walls. Although, since we can see here that there's still a really big bottleneck on our architecture station, it's causing problems with excess inventory, and so if we move across to our goods in area, we can see how fast our products are being consumed. Another issue observed that the MEP currently can't actually be fitted easily once the suspended ceiling has gone in, so we need to review the process on that. So just kind of looking to the general view on a high level, we've just had a look at our calendar view of basically everything which is happening, which is color coded against time along the horizontal on each of our stations. We've ended our simulation and managed to produce an output like you can see so. So if we go into our report, we have produced 6 modules which has met our requirement, and we can see that we can also show this report to our stakeholders, which has got all of the data for our rate, bottlenecks, efficiency and abnormalities. Although what we actually want to decide is that although we've met the demand of 6, 1 or 2 of those units are going to show signs of damage and so have to go for rework before they are then delivered to the customer site. And so effectively what we're going to do is we need to review our process anyway, because it flagged up lots of problems, and so that's what we're going to do in this next step. Okay, so like we found out in the simulation that we've just run on our initial factory performance, we noticed that there were some issues, one concern around the DFMA and worker safety aspect around one of the operations, which was effectively the MEP install, like we can see here. And so what we've done is we've effectively had a look at one of the operations where with the suspended ceiling already in, then the MEP would need to be installed at height due to poor access. Although we can then have a look at this in more detail because we've identified this early on in the design stage. We're going to simulate how this will be installed on site on the construction, and we can then hone back down and look at details within our factory, including using the ergonomic toolset, which is a specialist toolset within Delmia. Okay, and so following those improvements, we've also taken out the suspended ceiling and moved it onto the final station, like we can see here. And so now the way it flows is that only the walls and windows will be fitted at the architecture station, like we can see here. and this eliminates the need for working at height and improves on ergonomics. We're just going to skip through our shifts on our calendar view there, and now we can see that actually by moving that workload off the architecture station, we've outputted 10 finished modules, which has not only accounted for the 1 or 2 damaged modules needing rework, but it's also shown that the system is capable of responding rapidly and meeting ramp-ups in demand or changing product complexity. Okay, and so just some observations on that, just having a look. And so we determined that by doing our bottom and top frame assembly in parallel prior to the main structural assembly, we streamlined production. We've also noticed that before we balanced the line, there were idle times and delays to shipping finished units to the customer due to the bottleneck on the architecture workstation, which we can see. And there was also this issue with worker safety and DFMA when fitting the MEP once the suspended ceiling had already been installed. And we determined that although we've met the customer demand of 6 units in a week, we'd fail to meet that demand if we take into account rework, which needs to be done before the modules are delivered to site. And so in the second scenario, we managed to output 10 modules within the time frame, within a week. We've relieved the workload on the bottleneck and moved some of the work off the architecture station onto a less utilized station, being the same as the roof for the ceiling fit out. And we've reduced idle times effectively from easing of this bottleneck and streamlined the production. We also resolved the issue with installing MEP prior to the ceiling fit out, and we've eliminated the need for working at height. Although we want to do further investigations into postural analysis and details on further worker safety in our out of the box, off the shelf functionality within Delmia ergonomics. And we've also determined that we've exceeded our demand of 6 in a week, allowing for rework and changes in production. And so, if we just go on to the conclusion, just to recap on our goal from the start, we were asked to assess the industrialization effectively, and we've done this by creating manufacture bill of material breakdown in our MBOM, where this has enabled us to understand better our make or buy opportunities. We also created process sequencing and reviewed the build-up of how the product will be built once it is in the factory, and along with an early plant layout. We then used factory flow to assess how many stations we need, where are the bottlenecks, and what is the efficiency. And to finish off, we've also simulated what we call optioneering in the factory, because you're always going to have multiple solutions to a problem. And just to go back to what James said at the start, of course, the big value point here that we're using real data digitally to drive those optioneering decisions. And so with that, I'd like to say thank you very much. That's all the technical points covered, and I'd like to hand back over to James.